Good afternoon, everyone. Today I will be discussing the foundational concepts of comparative sciences, particularly in forensic analysis. We will discuss objectivity, subjectivity, types of logic used in forensic comparisons, the importance of form and pattern persistence, and the role of expert judgment. Let's begin. In forensic science, objectivity and subjectivity both play important roles. Objectivity is based on measurable, unbiased observations, for example, using precise instruments to measure a tool mark to ensure consistency and repeatability. And subjectivity, on the other hand, involves personal interpretation and personal experience. A fingerprint examiner, for instance, must rely on their expertise to determine similarities between prints. Both of these elements impact judgment because objectivity helps ensure consistency, while subjectivity, when guided by experience and structured methodology, allows for the interpretation of complex patterns. It allows the scientists to be adaptable and flexible if need be because they can draw on previous experiences to determine if there is a match or not. There are three types of logic that forensic analysts rely on, and the first one is deductive logic, which moves from general principles to specific conclusions. For example, we know that all fingerprints are unique, so if a fingerprint found at a crime scene matches a suspect, it must belong to them with this logic. The next logic, inductive logic, uses specific observations to form broader conclusions. If multiple shoe prints of the same design are found at different crime scenes, an investigator might infer that the same shoe type was used in each case. The third logic, abductive logic, involves making the most reasonable inferences based on available evidence. If a partial fingerprint is found, an examiner might determine that it is likely, but not definitively a match, and it needs verification. Pattern and feature persistence are some more concepts that are important in forensic comparisons. Form refers to the overall shape of an object, such as the tread design of a shoe, for example. Pattern includes the arrangement of details like the ridge flow in fingerprints. And feature persistence determines how long these characteristics remain unchanged. For example, bullet striations will remain the same unless the firearm's barrel is altered. These elements contribute to a uniqueness, allowing forensic analysts to differentiate between potential sources of evidence. There are two concepts that are important to distinguish between, and that is unique natural patterns and unnatural repeatable patterns. Unique natural patterns, such as fingerprints and vein patterns, are inherently different between individuals. No two fingerprints are the same. Unnatural repeatable patterns, such as manufactured items like tire treads, they can appear identical when new, but develop unique characteristics through wear and damage over time depending on how and how often the tires are driven on or used. Another example is while factory-made screws may look identical, close examination under a microscope will reveal small, unique imperfections that can help forensic analysts distinguish one from another. Experts use a systematic approach when determining if two pieces of evidence share the same source. They analyze form, pattern, and third-level details such as scratches or wear marks. The ACEV methodology, analysis, comparison, evaluation, and verification, guides this process. For example, in a case involving bite mark analysis, forensic odontologists compare tooth positioning, spacing, and unique dental features to determine a match. However, judgment in forensic analysis carries inherent risk, such as bias. Independent verification is crucial to maintaining accuracy and reliability. Forensic analysis follows three levels of detail for image comparison. Level 1 is the general form, which is used to determine broad class characteristics like whether a shoe print belongs to a boot or a sneaker. Level 2 pattern details examines more specific measurements such as fingerprint ridge flow or wear patterns on a tool mark. Level 3 micro details focus on fine textures, anomalies, and imperfections that make an object truly unique. The higher the level of detail, the stronger the comparison process, allowing more precise conclusions to be made. Level 3 details are necessary for making a positive identification. key factors in forensic comparisons are quality and quantity of details. Quality refers to the clarity of an image. For example, a smudged fingerprint may not provide enough detail for analysis. Quantity refers to the number of comparable features available. Even a small but clear section of a fingerprint may be sufficient for identification if it contains enough unique characteristics. Blurry images reduce confidence in forensic comparisons, while clear but partial images can still lead to reliable identifications. Forensic analysis faced several challenges. Environmental factors, such as evidence being degraded due to smudging, wearing, or contamination. Human perception biases, which is the risk of confirmation bias can affect subjective comparisons. Technological limitations, some forensic tools lack the resolution needed for precise measurements. And legal and ethical implications, forensic conclusions must be supported by strong evidence to avoid wrongful convictions. Addressing these challenges requires continuous improvements in forensic methodologies and technology. They both play important roles in forensic comparative sciences, and I think this is important to remember because objectivity is obviously always the goal, but subjectivity plays a big part in the comparison and adds a different depth to it. Forensic accuracy relies on a combination of scientific methodology, technological advancements, and expert evaluation. Forensic comparative science is continuously improving, blending scientific rigor with advanced technology to improve accuracy and reliability, making criminal investigations more accurate and reliable. Looking ahead, the field of forensic comparison is evolving with new technology and methodologies. Advancements in AI and pattern recognition, where machine learning can assist forensic analysts in comparing fingerprints, tool marks, and handwriting, is progressing every day. 3D imaging and high-resolution analysis, these techniques improve forensic accuracy by capturing microscopic details, and stronger standardization efforts, stricter protocols to help reduce bias and increase reliability. However, challenges remain such as balancing human expertise with machine learning and ensuring transparency in forensic methodologies. Ultimately, forensic comparative science is continuously improving, making criminal investigations more accurate and reliable. That's all I have today. Thank you for your time. I hope this presentation has provided insight into the foundational concepts of forensic comparative sciences. If you have any questions, I'd be happy to discuss any further. Thank you.